Hello everyone, today I will discuss about engineering probabilities and statistics with the topic regression and correlation. But what is regression and correlation? Regression analysis is a statistical process for estimating the relationships among variables. So under regression analysis is linear regression. Given a pair of data, a regression equation can be obtained. Regression equation may be of degree of 1, linear, 2, quadratic, 3, cubic, or higher polynomial. So, linear regression equation is derived from analytic geometry, which is y is equals to a plus bx, where a and b is the y-intercept and slope respectively. So given a sample of data with a number of students of 10, which has their midterm grade x-intercept and their final grade as their y-intercept. So to get the linear regression of this sample data, we must use the regression coefficients. So coming back with the formula, y is equals to a plus bx, where b is equals to the number of the total students times the summation of x and y minus summation x and summation y over the number of students times summation x squared minus summation x quantity summation x squared. So to get the A is equals to summation y over a minus b summation x over n.
Given the sample data for linear regression, we have 10 data for student number with proficiency exam scores and course grade. This x and y coordinates. So to solve for the linear regression and to get the equation, we must first complete the table. Multiplying x and y to get the x and y component, and squaring all the x values to get the x squared values and y squared values to get y squared. So we have now all the values we needed. Now we have to substitute it to get the value of b and a to complete the equation y. So substituting all the given values, n is equal to 10, summation of x and y, which is 55,875 minus 730, which is the summation of x, times 755, which is the summation of y, all over 10 times summation of x squared, which is 54,200, minus summation of x, which is 730 squared. So we have now all the values we needed. Substituting it with the given formula, we'll get a value of b with 0.84. Substituting again to get the value of a which is 14.80. Substituting the coefficients in the equation, we'll get y is equal to 14.80 plus 0.84. This will be the value of our linear regression.
Let's talk about correlation. When two variables are mathematically associated, they are said to be correlated. Correlation analysis measures the degree of relation between the two variables x and y by means of a single number called the correlation coefficient, or letter R. Coefficient of correlation has the range of R is greater than or equal negative 1 and R is less than or equal to positive 1. If R is equal to negative, there is an inverse relationship between x and y. It means that if x is increasing, then y is decreasing. If R is equals to positive, there is a direct relationship between x and y. If x is increasing, then y is increasing or vice versa. If r is equals to 0, then the two sets of data are uncorrelated. It means there is no correlation.
Where n is the total number of data, and it is widely used in the science as a measure of the strength of linear independence between two variables. Next, the Spearman-Rank correlation coefficient is introduced by Charles Spearman, a non-parametric measure of association between two variables x and y, where correlation coefficient is equals to 1 minus 6 summation of t squared all over n times the quantity of n squared minus 1, where n is the number of pairs of data and t is the difference in ranking of coefficient for each pair.
Given the following data, we are computing for the simple power equation. We have here 10 values of x and 10 values of y. So our n is equal to 10. Simple power equation has an equation of y is equal to a sub 1 times x raised to b sub 1. And it's for linearization, we have an equation of log y is equal to log a sub 1 plus b sub 1 times log x. For the value of y, we have y is equal to log y. Then for a is equal to log a sub 1. Then for x is equal to log x. Then b is equal to b sub 1. So we have to compute for the value of a and b. First, we have to calculate the new value of y and x, which is log x and log of y. So now we have a new value for x and y, and then we have to calculate the value of x squared, y squared, and x and y. It's log x times log y, log x squared, log y squared, then log x times log y. So now we have the value of x squared, y squared, and xy. Then substituting the value from the formula of b, we can get the value of b. Then substituting again the given value, we can get the value of a. We know that the formula to get the value of b is equal to n times the summation of x, y minus summation of x times summation of y all over n times the summation of x squared minus summation of x, then square n. Then substituting the value, since our n is equal to 10, 10 times the summation of xy, which is negative 1.10 minus summation of x, which is 2.0. 2.78 2.78 times summation of y, which is negative 1.36 all over n, 10 times summation of x squared, which is 1.52 minus summation of x, 2.78, then square. B is equal to negative 0.98. Now we get the value of B, which is negative 0.98. Then we have to get the value of A, which is, the formula is A is equal to summation of y over n minus B times the summation of x over n, then substitute, which then summation of y, which is negative 1.36 over 10 minus value of B is negative 0.98 times summation of x is 2.78 all over n, which is 10. So our A is equal to the value of A is equal to 0.1364. So we have the value of A. A is equal to 0.1364. Now we have to get the value of A sub 1 and B sub 1. A sub 1 is equal, we all know that A is equal to log A sub 1. So manipulating the given equation, we can get the A sub 1. So A sub 1 is equal to 10 raised to A. Then substituting the value of A, we can get A1 is equal to 10 raised to 0.1364, which is equal to 1.368. So A sub 1 is equal to 1.368. Then for the value of B sub 1, we all know that it is equal to B. So we have now the B sub 1. Then for the simple power equation, we have y is equal to A sub 1 times x raised to B sub 1. Then substitute the value of B sub 1 and A sub 1. We have A is equal to 1.368 times x raised to value of A sub 1 is equal to negative 0.98, and that's our simple power equation. Then for the Pearson product moment correlation coefficient, we have the formula of R is equal to N times the summation of x, y minus summation of x times summation of y all over is square root of N times the summation of x squared minus summation of x, then square of it, then times N summation of y squared minus summation of y, then square of it. Then substitute the given given values. So our n is equal to 10 10 summation of y is negative 1.1 minus summation of x is 2.78 times the summation of y, which is 1.36, all over this value is equal to n 10 times the x squared the square root, then x squared, which is 1.52 minus the x summation of x, then square of it, 2.78 squared, then times it to this, then 10 times the summation of y squared, that's 0.97 minus summation of y and the square of it, which is negative 1.36 and square. Then we have the value of r, which is negative 0.95. Given the following data, we are computing for the saturation growth rate or hyperbolic equation. We have here 10 values of x and 10 values of y, so our n is equal to 10. Hyperbolic has an equation of y is equal to a sub 1 times x over b sub 1 plus x. For linearization, we have an equation of 1 over y is equal to 1 over a sub 1 plus b sub 1 over a sub 1, then 1 over x. For the value of y is equal to 1 over y. Then for the value of a is equal to 1 over a sub 1. Then b is equal to b sub 1 over a sub 1. And x is equal to 1 over x. So we have to compute for the value of a and b. First, we have to calculate the new value of y and x, which is equal to 1 over x and 1 over y. So now we have the value of x and y, new value of x and y. So we have to compute, since we have to compute the value of a and b, first we have to calculate the x squared and y squared and the product of x and y, which is xy. Then substituting the value from the formula of b, we can get the value of b. Then substituting again the value from the formula of a, we can get the value of a. Since the formula to get the value of b is equal to n summation of x y minus summation of x times the summation y all over n summation of x squared minus summation of x then squared. Then substituting the value, since our value of n is equal to 10, Then, summation of x times y is 7.35. Then, minus summation of x, which is equal to 6.56. Then, summation of y, which is equal to 16.95, all over n, which is 10. Then, summation of x squared, which is equal to 6.82, minus summation of x, 6.56, then squared. We can get the value of b, which is equal to negative 1.49. So we have now the value of b, which is 1.49. So we have to get the value of a, which is equal to summation of y over n minus b times summation of x over n. So substituting the value, which is then summation of y is equal to 16.95 over n, which is 10, minus b, the value of b is negative 1.49 times the value of summation of x, which is 6.56, all over n. We can get the value of a, which is equal to 2.67. Then a is equal to 2.67. So we have to get we all know that a is equal to 1 over a sub 1, the equivalency of hyperbolic equation. So since we have the value of a sub 1, and then manipulating the given formula, we can get that a sub 1 is equal to 1 over a. Then substituting the value of a sub 1 is equal to 1 over 2.67. Then a sub 1 is equal to 0.374. Then a sub 1 is equal to 0.374. Then for the value of b sub 1, from the equivalency formula, we have b is equal to b sub 1 over a sub 1. Then manipulating the given formula, we can get b sub 1. b sub 1 is equal to b times the a sub 1. Then substituting the given value of a sub 1 then and b, we can get b sub 1 is equal to negative 1.49 times the value of a sub 1, which is 0.374. Then b sub 1 is equal to negative 0.5576. Then we now have a value for a sub 1, which is 0.374. Then b sub 1 is equal to negative 0.5576. Substituting the value from the hyperbolic equation, which is y is equal to a sub 1 times x over b sub 1 plus x. Then y is equal to 0.374 times x over b sub 1, which is negative 0.5576 plus x. Simplifying the formula, we can get y is equal to 0.374x all over x minus 0.5576. That's our hyperbolic equation. Then for the Pearson product moment correlation coefficient, since we have the formula of R is equal to N times the summation of X, Y minus summation of X times the summation of Y all over square root of N times the summation of X squared minus summation of X squared, then times to N summation of Y squared minus summation of Y then squared. Substituting the formula ay the given value, N is equal to 10, then summation of X of Y 7.35 minus summation of X 6.56, then summation of Y which is 16.95 all over is square root of N 10, then 6.82 minus summation of X then squared 0.56 squared times N 10, then summation of Y squared which is 42.73, then minus summation of Y 16.95 is squared. We can get the value of R which is negative 0.63.